Before we begin any lectures, let me just give you some tips and advice. As we're working through the lecture, I would encourage you to write it on your own notebook paper or print the notes ahead of time and fill them in as we go. This will be a great resource as you work through each unit in each section that we're going to cover this semester. If the video goes too fast for you at any point, just hit pause, catch up, and then hit play again. And if you have any questions after watching the full lecture video, feel free to Canvas message me any of your questions, comments, or concerns, and I'll be happy to help you one-on-one. So what we're going to start with is in Chapter 1 is just Section 1.1, and this being a pre-cal course, this is probably going to be a lot of review for you here at the beginning, but I want to start from square one, and I want to build a good foundation. So if there's any missing links along the ways or any things you've just forgotten since you first learned this, we can kind of fill in those gaps and then build from there. So in Section 1.1, we're going to first start with very basic level. We're going to start with our functions and our function notation. And so a function, let's just go ahead and define this. Our function is going to be a special relationship where each input has a single output. Or if you want it more in basic terms, your x's can't repeat. And this is probably the way many of you are going to remember how to do functions, but it is a special relationship where each input has a single output. The x's cannot repeat. We're not talking anything about the y's, we're just talking about the x's here. So kind of looking at a quick example to help us with that, let's consider set A in this example below. We're going to let it be our inputs. Another name for inputs might be domain, or better yet, it'll be our x's. And these are any of the ways that we can talk about that first variable. And then we're going to let set B be the outputs, or the range, there's a good word, good math vocabulary, or the y's. And so as we look at this diagram here in example 1, it is asking, is the following a function? So the way you kind of read this is what they're doing is they're pairing -3 with 3. And they're pairing -2 with -6, -1 with 0, 1 with -1, and 0 with 15. And so if you look at this and consider this to be your x's, and we're trying to see if the x's repeat, you can see that no arrow comes out of any of these numbers right here more than once. And so we would say, yes, this is a function. If we look at the next set, and again, the x's can't repeat, so we're only looking at this piece of information here, and we're trying to see if any of them repeat. You can see that right here, 1 is going to 0 and 1 is going to 15. And so right there, because of that situation of that double arrow, we would say this is not a function. Now this is not the only way that you would identify if something's a function or not, but this is just one example that I wanted to start you with so you can clearly see how everything is paired up and then address, is each input going to a single output. Now if we wanted to look at another special relationship, we have function, but we want to go a little bit more detailed or a little bit deeper, then we would talk about something called a one-to-one function. So not only does it have to satisfy that function definition, but now it also has to be one-to-one. And so one-to-one is defined as a function. Excuse me, let me write that a little bit neater for you. It is defined as a function, that's better, where each x value corresponds to exactly one y value. Or, again, you may put it in a little bit simpler terms. We're talking about x and y do not repeat. And so when we're talking about function, we're talking about the x's don't repeat. When we're talking about a one-to-one function, we're talking about our x's and y's don't repeat. And so again, let's kind of look at the same situation. We're going to look at the table of functions here and talk about, is it a function or is it one-to-one? So the first one kind of was a diagram. This next one is going to be a table. So as we look at this, notice that right here's your inputs. These are all of our x values, if you want to call them x's, or these are our domains. And if we're looking at just the inputs, you can see 2, 5, 8, 10, 12, 13, and this first one, I would say this first one is a function. My x's didn't repeat. We look at the next one again, we're just looking at these x values, and you can see that right here, there's a 0, and right here's a 0. So this one is not a function. Now the fact that it's not a function, we could also say that it's not one-to-one, because it has to not only satisfy being a function, but it has to satisfy the fact that the y's don't repeat. So if I can't get it to be a function, there's no reason for me to check if it's one-to-one. And again, next one, inputs, you're looking at these values right here. You look at them as a whole and you say, okay, did my x's repeat? And you can see right here at 5 and 5, it repeated. So again, this one is not a function. And we already know that it's not one-to-one. If it's not a function, there's no reason to even check if it's one-to-one because these x's repeat it. Now let's go in here and let's look at if our y's repeat it. Now I don't have to check the y's on this one or on this one because we already stated that they are not one-to-one. So let's check the y's on this first one. So I see 1, 3, 6, 5, 10, 9, and that all looks really good. Nothing's repeating. So on this one we can say this one is also one-to-one. And so in your homework, these are some of the things that you're going to have to do. You're going to have to analyze the data, and based off what is given, you're going to have to figure out, is this a function or is it one-to-one? Now there are other ways of figuring out if functions are if they are functions or one-to-one. These are just on diagrams and tables. So let's kind of roll into the next part here. Again, pause at any point if you need to slow down or catch up on your writing. So let's look at determining a function graphically, and we do that by the vertical line test. And so most students really love this vertical line test because it's a really quick way to check if something's a function. And so we're going to look at these and say, which of these graphs defines a function? And then after we do that, vertical line test, we're going to look at them and say, which of these graphs defines a one-to-one function? And what you're going to do is, you're going to first check for your vertical line test for function, and then for your one-to-one function, you're going to be checking the horizontal line test. And so I didn't really write out a definition for either of these because I really think a visual is going to help you the most with this. Okay, so when you're doing this, let's first look at the vertical line test. On the vertical line test, just kind of switch this over here. On the vertical line test, you are going to say, could I draw a vertical line anywhere on that function? And when I do, does it cross it more than once? And so you can notice here, if I drew a vertical line anywhere on this function, it's only crossing that blue line once. And so I would come down here and say, this is a function. And then I would do the same thing with the next one, and I would draw vertical lines anywhere I could and say, okay, is it crossing that blue line more than once? I never could find a bad line, so again, I would say this is a function. Now on this one, notice I could draw a vertical line right here, but I'm not looking for a good line. I'm looking for one bad line. So I come in here, I go, whoop, right there's a bad line. If you want, here's a bad line. But it only takes one to ruin it. So this one would not be not a function. Now let's come in here and do the horizontal line test. It's the same kind of concept. If you can draw a horizontal line anywhere on the graph and it crosses it more than once, then it's not a one-to-one function. So notice here, I could draw a line here, it crosses it once. I could draw one here and it crosses it once. But I'm not looking for a good line. I'm looking for a bad line. So notice if I were to draw one here, it would cross it many times. And so this one would be not one-to-one. Now if I come over here to this next one, okay, that one works, that one works. You can see I could draw a horizontal line anywhere on that one. And so this one is a one-to-one function. Now this one already got kind of killed out here with the vertical line test, but look, I could draw a horizontal line and also do that too. But the fact that it's not a function, I already know that it's also, not one-to-one too. So I just want to kind of show you some good examples and some bad examples on how those things are functions or one-to-one functions using a graph. Now, not everything we're going to do is going to be on a graph because we don't use a graphing calculator as we're doing things. And so let's come down here and let's just kind of look at an example that you're going to be given. It says, given the graph here of f of x, so given the graph here of f of x, let's evaluate f of 2. Then I also want to solve for f of x equal to 4. And so I'm going to kind of use this graph and kind of read some information. Now if you remember back to when you learned function notation, you learned that instead of writing y, we typically write f of x, kind of a formal definition, or no, a formal name for it, if you like. Y is kind of the nickname, but f of x is the formal name for it, and we're in pre-cal, we're in college, we're taking this class, and so we're going to use that college f of x. And you'll notice that when I went from f of x to 2, that just meant that x was now written as 2. So now, instead of saying x is equal to 2, we're going to say f of 2, and I'm not going to do anything with this in the fact of I'm not going to solve for f, I'm not going to divide by 2. I want to find the function value at 2, and so right here's my 2 on my x, and so I'm going to grab this point right here, I'm going to grab that y value. So I can now see that f of 2 is equal to 1. And again, this is my x value, and this is my output, or my y value, and I'm just reading that off a graph. So knowing all of this, when I go in here and do f of x is equal to 4, this is my y value. So I'm going to go on my graph to where y is 4, which is right here, and I'm going to grab that value. And so it says, essentially, x is what? X is what when y is equal to 4? And so we can see here by looking at the graph, it would be at this point and this point. So that would be, let's see, x equals -1 and x is equal to 3. And so we can see from just pulling this data that those two x values goes to the same y value. And so just added bonus here, this is not a one-to-one function. But I just want to kind of emphasize on function notation and how you could work with that, how you could read it. What is your x and what is your y? So again, in this one, we're just kind of filling in some gaps in our knowledge, giving us a good foundation for this wording and vocabulary as we move forward in this course. And so now let's look at determining a function algebraically. So what you want to do is you want to solve for y, and if you plug in x and get one, emphasizing there, one value of y, then it is a function. Because remember, this input only goes to a single output. And so in example 4, it says express the relationship as a function if possible. And it gives us this equation, 2x plus 6y equal to 12. And so here's what I want to do. I want to kind of look at this. I want to go ahead and solve for y. So let's follow this first part, and I want to solve for y. And so here's my y value, and I want to get it by itself. So I'm going to say minus 2x, which gives me 6y equal to negative 2x plus 12. And then divide everything by 6. So it gives me y equal to negative 1/3 x plus 2. So now that I have y by itself, it says if you plug in an x and get one value, then it's a function. And so I'm just going to think about this. Okay, if I plug in one value of x, am I going to get just one value of y? Yes, because plugging in a value right here for x, I would multiply by negative 1/3 and add to 2. So it only has one output. So yes, that would be a function. And we also know it because that's a linear function. And we're going to talk about that later on. So in the next example, it has x squared plus y equal to 1. And so if I look at this one and I solve for y, so I'm saying minus x squared. That gives me y equal to 1 minus x squared. And so again, if I were to plug in an x value there, I would square it and then do 1 minus that number. I would only get one y value. So you know what? Part B, that's a function too. Let's look at this last one here though. Say we had y squared plus x equal to 1. So let's solve for y. So I subtract x. That gives me y squared equal to 1 minus x. Move up a little bit here. And then I square root. So this gives me y equal to. But remember, when you square root a variable, and you probably learned this in our prerequisite courses or courses before this, when you square root a variable, you have the chance of giving a positive or negative out of that square root of 1 minus x. And so you can't forget this little piece of information right here. So now, if I were to plug in an x value, I would actually get two values for y, because again, when you square root a variable like this, the final answer could have been positive or negative. And so this one right here is not a function. So kind of interesting there. When we're looking at functions, we can look at them from a diagram, we can look at them from a table, we can look at them from a graph. And so the last thing I want to kind of do here is I want to kind of look at just your basic toolkits or functions, or I want to consider all your parent functions. So definitely, if it goes too fast for you, pause it and jot this down. These parent functions we are going to reference and reference and reference. We're going to talk about. So let's take a moment and look at a bunch of different parent functions, not all of them, but kind of some of the ones that we're going to use during this course, and let's talk about some information from them. And so the first thing I want to notice here is something called the constant function. This constant function is the equation f of x equal to c. If we begin to talk about its x's or y's, remember we already said x's was our domains and y's were our range. So the domain on, this function, domain is your x's. So let's maybe jot this down up here just to remember. Domain is your x's and range is your y's. And I always remember this because they're kind of in alphabetical order. D comes before R, X comes before Y. So the domain of this function, the all possible X values would be all real numbers, or all of them. And so if you want to write all real numbers, you just kind of write an R with a stem on it. And then your range is just going to be whatever your Y is. So Y would be equal to C. You also notice some other characteristics. And I'm just trying to pull out characteristics about these parent functions to make sure we understand all the different things about them. So like this point here is our y-intercept. And so it will always have a y-intercept at 0, c. And x-intercepts, well, it doesn't really have one. The only reason it would have one, it would be all real numbers, and that's if and only if your c is equal to 0. So if you have that horizontal line running on the x-axis itself. A more familiar one is the identity function, and that's f of x equal to x. We're real familiar with that. Its domain is all real numbers. There's no x's that we are going to not use. Its range is all real numbers. Again, we're using all possible x's and y's in that one. And it has an intercept, or its intercepts is at 0, 0. You can see it's crossing through the origin there. The absolute value function is f of x equal to the absolute value of x. It has a domain of all real numbers, but you can see that its range, well, its possible y values, you can see all the y values are up here in this positive quadrants here, and so its range is going to be y is greater than or equal to 0. It does have an intercept right here, so its x and y intercepts are at 0, 0. So there's 3 of our parent functions. Let's kind of move down here into the next 3. We've got our quadratic, which is f of x equal to x squared. It resembles a U shape. Its domain is going to be all real numbers, so going left to right, we're going to use all possible x's. Its range is going to be y is greater than 0, so again, all of its y values are going to be in this top quadrant. And it has intercepts, again, right there at that origin. You'll notice a lot of these parent functions kind of revolve around the origin, either intercepting it or just kind of symmetrical off of it. Then we have our cubic function. This cubic function is f of x equal to x cubed. It has a domain of all real numbers, and it has a range of all real numbers. You can see left to right, it is getting bigger and bigger and wider as it goes off to infinities. And it has intercepts at 0, 0. The square root function is f of x equal to square root of x. Again, all these parent functions are just the most basic functions, the parents to all the square roots, if you like. It has a domain of x being greater than or equal to 0. It has a range of being y greater than or equal to 0. And you can see it's going to start here and then go off. And so again, it has that intercepts at the origin. 3 more, and we'll finish this up. So the cube root function, this is f of x equal to the cube root of x. It has a domain of all real numbers. It has a range of all real numbers, so it's getting wider and wider, similar to what we saw with that cubic. And you can see it's crossing here, so it has those intercepts at 0, 0. And the next one, the reciprocal function, this is f of x equal to 1 over x. It has a domain such that x cannot equal 0, and it has a range such that y cannot equal 0, and you can see that there's like these imaginary lines where it's not touching those axes. So we're taking the 0 out, and you can see that too because we're dividing by x here, and we can never divide by 0 in a math class. And this one has no intercepts because of that. And then our last one here, the reciprocal squared, this would be f of x is equal to 1 over x squared. It has a domain such that x cannot be 0, and again, it's all because we have that division by x. And its range is y is greater than 0. You can see because everything is happening up here in these top quadrants. And again, this has no intercepts because it's not crossing either of those. All right, so I just want to kind of give you a basis here of these parent functions and the domains and ranges, etc. Because as we work through and we go through different chapters, we are going to keep referencing like intercepts and domain and ranges. So this gives you a really good resource. Again, if at the conclusion of this lecture you have any questions, comments, or concerns after hearing this, I would take your notes, go try the homeworks, and then Canvas message me any questions you need additional help with. There's also resources available to you at the bottom of the lecture page.